So we'll solve some other problems. Find the trigonometric Fourier series for the periodic signal given below. So this is a periodic signal. It's a square periodic signal. Your x of t is given in the y-axis and t is given in the x-axis. So this is in the y-axis. X of t versus t. Y with x. And of course you have the maximum amplitude is nothing but your 1. So this is your 1. So it's a step of function. See here 1, 0, 1, 0, 1, 0. Your x of t is nothing but your 1 in this interval 0 to 1. And 1 to 2 it is 0. See here it is 0. There is no signal. Here there exists signal. So here it is 0. Here it is 1. And we know that the total wave is nothing but 0 to 2. So your 0 to 2. So your t is nothing but your 2. Small t is there. So capital T is nothing but your 2. So it varies 0 to 2, 2 to 4, 4 to 6, goes on. So omega equal to 2 pi by t, we know already the frequency. 2 pi, instead of t you substitute 2. So omega equals pi. So wherever you find omega, you can substitute pi. The first idea. Now what is asked? Fourier series is asked. Now we'll have to calculate the DC term, the constant term in Fourier series, which is given as a naught equals 1 divided by t x of t dt. Instead of x of t, you have to substitute 1. So 1 dt with this interval. So 0 to 1. So 0 to 1, 0 to 1. Here it is 0. So 0 to 1. Now substituting the upper limit will give us 1. So that will give us 1 by 2. Your a naught equal to 1 by 2. Now we'll go for an. An is the constant term for the cosine term. So we have 2 divided by t x of t cos n omega t dt. Instead of x of t, you have to substitute 1. See here, x of t is nothing but 1. 1. So we have 1 cos n omega t dt. Instead of omega, you can substitute pi because already we have found out pi. So instead of omega, substitute pi here. So cos n pi dt. Integration that will give us 2 will get cancelled. Integration that will give us sin n pi t divided by n pi 0 to 1. Okay, so we have 1 divided by n pi. Substitute in the upper limit will give us sin n pi. Substitute in the lower limit will give us sin 0. Sin n pi minus sin 0. What is sin n pi? Sin pi is 1. Sorry, 0. Sin 2 pi also 0. Sin 0 also 0. So this is 0. This is 0. That will give us 0 term. So an equal to 0. Now we will go for bn. Bn equal to 2 divided by t integration 0 to t x of t sin n omega t dt. So instead of omega, you have to substitute pi. So sin n pi t dt. Integration that will give you this term. On integration will give us minus cos n pi t divided by n pi. Substitute in the upper limit will give us cos n pi. Substitute in the lower limit will give us minus cos 0. And of course cos n pi is nothing but minus 1. Cos pi is minus 1. Cos 3 pi is minus 1. So we have minus 1. Cos 0 is 1. So we have minus z, so minus z. So that will give us minus 2. This minus and this minus will become plus. That will give us 2 divided by n pi. So your bn is nothing but 2 divided by n pi. An equal to 0. So now this is 2 divided by n pi. As I said just now, for 1 cos n pi, cos pi, cos 3 pi, cos pi, all will become minus 1. Whereas if you substitute even numbers, cos 2 pi, cos 4 pi, that is 0. For all the even, it is 0. For all the odd, it becomes 2 divided by n pi. So substituting in the Fourier series. So we have a naught. Instead of a naught, we have got the answer as 1 by 2. An is 0. Correct? An is 0. Already we have calculated. See, an is 0. And bn is nothing but for all the odd number 2 divided by n pi. So 2 divided by n pi for all odd. For all the even numbers, it becomes 0. So this is the answer. Now we expand. 2 divided by n pi. First we expand. So that will give us odd number. So 1, 3, 5 goes on. So we will have to substitute only 1, 3, 5. So 2 divided by pi sin omega t. Okay, already we have written only omega. So instead of omega naught, you substitute omega. So that's a mistake here. It is not omega naught, it is omega. Omega. So we have omega sin omega t 2 divided by 3 pi sin 3 omega t plus 2 divided by 5 pi sin 5 omega t goes on. This will work out only for the odd numbers. 1, 3, 5 goes on. Okay, so this is the expected Fourier series. Now, this problem is very, very important. Find the Fourier transform of Gaussian function. So this is Gaussian function. Gaussian function is nothing but e power minus ax squared. So far we have learnt e power ax, e power plus ax, e power minus ax. These are all exponential functions. Whereas this is e power minus ax squared. So your ax squared. So it's a parabola. It's like a bell shaped, inverted bell shape. Okay. What we call this as Gaussian function. So this is Gaussian function. Normal distribution, inversion of normal distribution. So we have Gaussian distribution is given by this expression. So your f of x is nothing but e power minus ax squared. It is not ax, it is x squared. So far we have seen so many problems with e power minus ax, but here e power minus ax squared. So it's a Gaussian function, Gaussian distribution. What is asked? Fourier transform is asked. So Fourier transform of f of x equal to 1 divided by 2 pi f of x e power I omega x. So here x with omega. Okay. Instead of f of x you have to substitute e power minus ax squared. So e power minus ax squared times e power I omega x. Now there's a trick here. We are going to solve. What we are going to do is we are going to add this term and subtract this term. So here we have the same term here. We are going to add this term and we are going to subtract. So no, there will be no change. When you are going to do, just take first three terms. First term, second term, third term. We can make this as a square term. We can make this term as a square term. Like for example, we know that a minus b whole square, which is equal to a squared plus b squared minus 2ab. So we are going to make these three terms. Instead of these three terms, we are going to make as a square term. So this square term can be written as like this. See, we know that x root a minus I omega divided by 2 root a whole square, which is equal to a square plus b square minus 2ab. Correct? This is the formula we know. So you just square this term. So you have x squared, root a squared is nothing but a. So ax squared. See here, ax squared. You square this term, that will give us I omega whole square divided by 2 root a whole square. Correct? I omega divided by 2 root a whole square. We know that I squared is minus 1. So that's why I written as minus n here. Okay, we have omega square divided by 4a. Okay, 4a. And here it is nothing but minus 2ab. So minus, you have 2a, this is your a and this is your b. See, 2ab. See here, 2 is here, your I is here, your x is here, this x is here, root a is here, omega is here, divided by this term, 2 root a, 2ab. So instead of this, we can write, see this is same thing, see here, same thing here. So instead of this, we can write these two and these two will get cancelled. Okay, we have ix divided by root a, see here, ix divided by root a will get cancelled. So we have I omega x, see here, I omega x. See this term, omega square divided minus 5. I can pull minus sign out. Here it is plus here. I can pull minus sign out. This minus sign. So this becomes plus. This becomes minus. This becomes minus. I can pull minus sign out. So this will give me plus, minus, here minus. See here exactly it is the same. So instead of three terms we can write the square term. I have written square term pulling minus sign out. Remaining term will be this term. So e power minus omega squared by 4a. Now I am going to keep this term as y. I am going to keep this term as y. So this becomes y squared. See, this becomes y squared. I am going to keep this term as y. So x root of a minus I omega divided by 2 root a, which is equal to y. Now differentiate. This term will become 0. With respect to, see here, this term alone will give us dy root a dx. So wherever we find dx, we substitute dy by root a. So just take the Fourier transform. Fourier transform, that will give us 1 divided by root 2 pi root 2 pi. Instead of this term, you have to substitute y. So this becomes y squared, e power minus y squared. And the next term will be e power minus omega squared for 4a. I written same thing. The next term will be dx. Instead of dx, you have to substitute dy by root a. See, dy by root a. Now I can pull all the constant term out. So 1 divided by root pi. E power minus y squared is here. Because we have to integrate with respect to y. E power minus y squared is here. And this is without y. So I can pull it out. This is 1 by root a. I can pull out. Okay. So we have 1 divided by root pi. This term. And this is your even term. E power minus y squared times dy is a even term. Whenever you substitute y, instead of y you substitute minus y, will give us plus y. See here, because this is square term, this become okay. So here this is even term. Even function means you can, instead of limits, you have to substitute 2 times 0 to infinity. So for the even function, you have to substitute 2 times. So even function. So this becomes 2 times 0 to infinity e power minus y square dy. So we have to integrate only this term alone. Easy to integrate, because we know the formula 0 to infinity x to the power n e power minus ax to the power m dx equal to this formula. This is in terms of gamma integral. So this is gamma. This time, first time you are going to learn. So this is gamma integral. So gamma is termed as like this. And here you substitute n equal to 0. You substitute x equal to y, a equals 1, m equal to 2. You will get this one, e power minus y square. You just substitute, let us see, you substitute n equal to 0, x to the power 0, that is 1. You substitute now y, x equal to y, so y to the power m equals 2, so y square, a equal to 1. So that will give us this term, e power minus y square. Okay, so that will give us 1 divided by m. Instead of m, you have to substitute 2, so 1 by 2. 1 divided by a is nothing but 1. 0 plus 1 divided by 2, gamma 0 plus 1 by 2. So 1 by 2 is here, 1 by 2 is here, this becomes 1 here, and you have gamma 1 by 2. Gamma 1 by 2 is nothing but root pi. So you have to remember, gamma 1 by 2 is nothing but root pi. So we have now the integral 0 to infinity e power minus y square dy is nothing but 1 divided by 2 root pi. So this is the origin one. So that's why I have written as minus into plus infinity e power minus y square dy equal to 1 by 2 times root pi. Now substitute. So that will give us 1 by divided by root pi. This term only we have calculated. This is nothing but root pi by 2. So this term only we have calculated. These two and these two will get cancelled. This root pi and this root pi will get cancelled. We have 1 by root 2. Here will be 1 by root a, combined together 1 by root 2a, and this is your e power minus omega squared by 4a. I written this. So this is the answer. Okay, so Fourier transform of f of x, which is nothing but your Gaussian distribution. Gaussian function is nothing but e power minus omega squared by 4a divided by root 2a. Now this is the answer. Now we can go with the different terms. For example, when a equal to 1, this answer becomes this one. When a equal to 3, this answer becomes exactly like this. So this is just an addition. Okay. Now Dirac delta function. Dirac delta function is nothing but, most probably will be using only in quantum mechanics. So minimum we will have 2 variables, x and x prime. For any Dirac delta function we will have 2 variables. Okay, here it is t and v. So there will be 2 variables. One is x, another one is x prime. When x prime tends to x, the answer is 1. So this is called the Dirac delta function. Elsewhere it is 0. Here it is 0, here it is 0. When this is x prime and this is your x. When x prime tends to x, the answer is 1. Elsewhere it is 0. Here it is 0, here it is 0, here alone it is 1. This is called the Dirac delta function. So Fourier transform of f of t equal to 1 divided by root 2 pi f of t e power minus I omega t. This f of t is replaced by Dirac delta function. See, this is Dirac delta function. Del t minus a and e power minus I omega t dt. So this is Dirac delta function. And instead of this, you just substitute f of x. So we have now f of x del x minus, this is the general formula. As I said just now, you have x and x prime. So x and x prime dx equal to f of x prime. So Fourier transform of Dirac delta function del x minus a is given by 1 divided by root 2 pi e power minus I omega a. Instead of t, let us substitute a here. See, and that will give us minus into plus infinity f of x del x minus a. Instead of x prime, we just substitute a dx equal to f of a. Okay, so Fourier transform of del of x minus a equal to 1 divided by 2 pi e power minus I omega a. Suppose I substitute a equal to 0, that will give us del x equal to 1. So this is your Dirac delta function. Now the last one in the title is nothing but convolution theorem. So this is the last topic in the unit, convolution theorem. So the convolution of two functions. Convolution means the product, multiplication, and there must be minimum two functions. So we have one function is here, another function is there. We are going to multiply the product of these two signals. Most probably this convolution is used only in electronic circuits. Okay, in digital electronics and analog electronics it is used. So the convolution of two functions f of x, g of x. See, this is convolution. The symbol is convolution. Okay, the star. Okay, asterisk. F of x convolved with g of x. This is convolved with, which is nothing but the product. So f of x star g of x is given as 1 divided by root 2 pi minus infinity to plus infinity f of u g of x minus u du. We are going to prove this one. The Fourier transform of convolution of f of x, g of x is given is nothing but the product of Fourier transform. The product of Fourier transform. So your Fourier transform of f of x convolved with g of x is nothing but this. See, for example, Fourier transform of f of x is nothing but f of s. Fourier transform of g of x is nothing but g of s. So this is multiplication. This is convolution. The product. Fourier transform of f of x is nothing but f of s. Fourier transform of g of x is nothing but g of x. So this is just multiplication, and we are going to prove this one. So we know that f of x dot g of x is given by this. F of x convolved with g of x is given by this. We know already. Now, so we know that any Fourier transform of f of x is given as 1 divided by root 2 pi minus into plus infinity f of x e power I s x dx. We know already. Now taking the Fourier transform on both sides. Take the Fourier transform on both sides. So you have f of Fourier transform of f of x g of x, which is equal to 1 divided by 2 pi. We will have to take the Fourier transform f of x g of x e power I s x dx. Just take the Fourier transform of on both sides. So we have 1 divided by 2 pi minus into plus infinity, and this can be written as f of u. Already see, f of x g of x nothing but f of u g of x minus u e power I s x du dx. Now you just pull f of u this side, 1 by 2 pi. Remaining term g of x minus u e power I s x dx du. This term is nothing but Fourier transform of g of x minus u, because this is g of x minus u. This is g of x minus u. So that's why we written as Fourier transform of g of x minus u. This is f of u. F of u multiplied by f of g x minus u. F of u multiplied by f of g x minus u. By shifting problem, this is nothing but g of s. So this will give us f of u e power isu g of s du, and here f of u is nothing, here f of u is here, and this can be written as exactly g of s. See, g of s is I have pulled out. So this is g of s 1 divided by 2 pi f of u e power isu du. What is this one? This is the Fourier transform of s. So gs is here, fs is here. So Fourier transform of f of x. This is the left hand side. See, left hand side is Fourier transform of f of x dot g of x. So Fourier transform of f of x convolved with g of x is nothing but Fourier transform of f of s multiplied by g of s. So we have proved this one. So this is the convolution theorem. Convolution is nothing but the product of two signals. Now let us try to solve one or two problems using convolution theorem. So which is equal to this. We are going to find out the convolution theorem to find f inverse 1 divided by 6 plus 5is plus s squared. Take the denominator. We are going to factorize this one. So 6 plus 5is minus s squared. Just add. So this 5 can be written as 3 plus 2. Okay, 5 can be written as 3 plus 2. So 3is plus 2is. We can factorize this one. See, this is factorized. 3 plus is multiplied by 2 plus is. See, 3 2s are 6 here. 2 6 here. You just multiply, you will get I squared s squared. This multiplied by this multiplied by this will give us 3is plus 2is. See, so we can factorize this. So denominator can be factorized this one. So Fourier inverse transform will be 1 divided by, instead of this you substitute the factorization. See, we have factorized. Individually you can do. This is for the convolution theorem. See, this is together. Individually we can do. So this is together. This is together. Individually we can do. So this is what the Fourier convolution theorem. See, we have individually we can do. By inverse Fourier transform, f inverse equal to 1 divided by 3 plus is is nothing but e power minus 3t h of t. Anything you can write g of t. So you can write h of t. So we have f inverse. Similarly for the second term, that will give us 1 divided by 2 plus is e power minus 2t ht. This is for the first term. This is for the second term. We are going to multiply these two and get the answer. So as I said, we are going to multiply these two and get the answer. And we know that the convolution theorem is like this. F of u, g of t minus u du minus into plus infinity. The first one is e power minus 3u h u. So I will change the term. Instead of t, I will substitute u because of the convolution theorem. E power minus 3u h u e power minus t 2 t minus u times. This is your h t minus u du. What is this one? E power minus 3u e power minus 2t minus u. So this is e power plus 3u. Here it is minus 3u. That will become e power minus u. And this is e power minus 2t. Correct? I have pulled e power minus 2t out. I repeat here, e power minus 3u. Here it is e power plus 2u. So minus 3u plus 2u will give us minus u. See, e power minus u. Here it is e power minus 2t. I have pulled out. Remaining term h of u, h of t minus u is here. Now minus infinity to plus infinity it has been given. So minus into plus, minus into 0, it is 0. 0 to 1, that will give us e power minus u 1 du, and here it is 0. That's the limit. Okay, so we have now this is 0 and this is 0. We have only this term allowed. So which is given as h of u, h of t minus u, which is equal to, in this interval this is 1, in this interval this is 0. So that's why written 0 here. So we have now e power minus 2t, see, e power minus 2t, e power minus u du in this interval. So we can write e power minus 2t here, e power minus u on integration, that will give us e power minus u divided by minus 1. So I have written minus e power minus u 0 to t. It is given as t. Upper limit is t. See, 0 to t. So e power minus 2t minus e power minus 2t. Substitute the upper limit, will give us, instead of u substitute t. So minus e power minus t. Instead of u, you just substitute lower limit, which is nothing but 0. So e power 0, which is nothing but 1. So we have plus 1. Already one minus is there. That minus and lower limit, we are going to substitute the lower limit, that will give us plus. So plus 1. So now e power minus 2t multiplied by minus e power minus 2t will give us minus e power minus 3t. This one on multiplication will give us e power minus 2t. So this is the answer. Okay. Similarly, you can solve the last problem. F inverse, which is nothing but 1 divided by 12 plus 7 is minus s squared. As usual, we will have to factorize the denominator. So we will have to factorize the denominator. 7 is can be written as 3 is plus 4 is. We can factorize. So instead of this, we will have to write this one as usual. So now you look at separately, we can write using convolution theorem. See, convolution theorem, we can separately we can write. Now the first term will give us e power minus 3t h of t. The second term will give us e power minus 4t h of t. So instead of this, you can write e power minus 3 h of t, e power minus 4t h of t. Now you have to use convolution theorem. Convolution theorem says that wherever you find t, you have to substitute u. So e power minus 3u, h of u, e power minus 4t, you have to use another one. So 4t minus u, h of t minus u. T minus shifting property. See, h of t minus u. Now in e power minus 4t, this becomes e power plus 4u. You combine together, that will give us e power u. Remaining term will be h of u, h of t minus u, and you can pull e power minus 4t out. And in this interval this is 0, in this interval this is 0, this alone will exist 0 to t. So we have h of u, h of t minus u will give us 1 in this interval, u lies between 0 and t. The answer is e power minus 4t. This is e power u. Integration will give you e power u divided by 1, e power u divided by 1, 0 to t, e power minus 4t. Instead of substitute, the upper limit will give us t, lower limit will give us minus 1. So e power t minus 1. Multiply will give you the complete answer. So you have e power minus 3t. See, e power minus 4t multiplied by e power t will give us minus e power minus 3t. E power minus 4t multiplied by 1 will give us minus e power minus 4t. So that is the end of the 4th unit. We have finished Fourier series and Fourier integral. Fourier integral, Fourier transform. Okay. Thank you, students. We will see you in the next class.